In this video, I'm going to go over Exploration 7.4a, where we're now going to look at arc cosine, arc sine, and arc tangent. So the first one asks us to find the degree measure of arc cosine of 0.4 that will equal the cosine inverse. And so I know cosine inverse is defined in the first and the second quadrant, and since my ratio is positive, that tells me that this angle will be found in the first quadrant. So this right here is going to be the angle of the cosine inverse of the ratio 0.4. So making sure that our calculators are in degree mode, we can find this angle. And so I will type in the cosine inverse of 0.4. And I end up getting about 66.422 degrees. So we could draw in this reference triangle. And since my ratio is 0.4, we could write the adjacent side as having a length of 4, and my hypotenuse having a length of 10, since 4 over 10 would equal 0.4. The second one is asking us to sketch another angle for arc cosine of 0.4 in a different quadrant. So remember that arc cosine wants to find multiple angles where the ratio is 0.4. And so since my ratio is positive, I know that cosine is positive in the first and the fourth quadrant. And so I'm going to go ahead and draw in another angle, which puts me down in the fourth quadrant. And since these ratios are going to be exactly the same, I know that this reference angle is just negative 66.422 degrees. I could also go around the positive way and add 360 to get other answers. So my first answer was the 66.422. My second answer for theta is approximately equal to negative 66.422 degrees. So my general solutions to find all of the answers, I could start here, add and subtract 360 to get more, or I could start here, add and subtract 360 to get more. So my general solutions, positive 66.422 degrees plus 360 n. Could add different multiples of 360. Theta would also equal negative 66.422 degrees plus 360n. And we call these general solutions because we can add and subtract multiples of 360 to get as many as we want. So now we're going to look at a similar problem using arc sine and sine inverse. So right away, if we're talking about sine inverse, I know that sine inverse is defined in the first and fourth quadrant. But again, you want to look at your ratio, and since my ratio is positive, I know that sine will be positive in the first quadrant. And so this is the angle that will be found by doing sine inverse of 0.3. Again, making sure that your calculator is in degree mode, we'll do the sine inverse of 0.3, hit enter, and so my angle in the first quadrant is approximately equal to 17.458. And that's this reference angle right here, 17.458. And so since my ratio is 0.3, the opposite side we could write as 3, where the hypotenuse would be 10. Now arc sine wants to find more than one answer. And so sine is also positive in the second quadrant. And my calculator doesn't give me that answer, so we're going to have to use this reference angle to find it. I know that if this is 17.458, then this reference angle is also 17.458 degrees. And so to find this entire angle, I'm going to take 180 minus 17.458. And even though I rounded on my paper, use the entire answer in your calculator. And so my other angle will be approximately equal to 162.542 degrees. And so those are the two locations where the sine would have a ratio of 0.3. Again, my calculator only gives me one answer, so then we have to use what we know to find the second. So my general solutions, theta will equal 17.458 degrees, and we could add and subtract multiples of 360 to get more. Theta will also equal 162.542 degrees, add multiples of 360 to get more.